Okay, hello student. Today we are going to learn about introduction to electricity, and in this class we will learn also about the concept of charge. We will be introduced to the first time view for class 10 student, and we'll learn about what is static electricity and what is electric potential, and then what is electric current. And then this electric current will be the dynamic electricity. And electric current we will do only about the conventional current, because there are electronics current and conventional current. We will do only conventional current. Okay, then we will start first with charge. And what is this charge? Okay, now before we understand to know what is charge, and then first we have to know what is valence electron. What is valence electron? To know from where we got a charge, we have to know first what is this valence electron. Okay, this valence electrons you have studied it in previous classes. Okay, maybe some students already know it and some students maybe don't know it. Okay, then we look at valence electron. Valence electron means the outermost electron. The outermost electron in an atom. Okay, what's the meaning of this? Outermost electron in an atom, or we can call them as free electron. Or we can call them as free electrons. What is free electron? Free electrons mean they are free to move, free to jump from one atom to another atom, or free to jump from one matter to another matter. Okay, what is this outermost electron? Like in previous class, you studied about the structure of atom. In previous class, you studied about the structure of atoms. That inside this atom there is a nucleus. Then outside this there will be a shell. This we will call as a first shell. Okay, first. Then this we call as a second shell. Then this we call as a third shell, and so on. 1, 2, 3, 4, 5. I don't know how many because I don't take any example of elements. Okay, so this is nucleus. Now inside the nucleus there is only proton. Inside here there is only a proton and plus neutron. But this proton is a positive charge. Then in this first shell there is some electron. Then in this second shell also there is some electron. Then in this third shell also there is some electrons. Now from here, this first shell is the inner shell. This is the inner shell. Then this second also is inner shell. But this third is the outer shell. Now those electrons who are on the outer shell will be called as free electrons or outermost electron. Mean the outer. Mean they are far from where? From the nucleus. They are far from where? From the nucleus. Now this is a negative and this is a positive. There is a force of attraction between a positive and a negative. There is a force of attraction. Then this also force of attraction by what? By the nucleus. Now this electron on first shell is held by the nucleus. Then this electron on second shell also is held firmly with the nucleus. But this outermost shell, means the force keep on decreasing because they are very far from the nucleus. This outermost. These outermost are very far from the nucleus. Then the force of attraction are very small or become weaker. Then those electrons who are on this outermost, they are free to move. Why they are free? Because the force holding by the nucleus to this outermost are very weak. Then they can easily jump or they can easily move. Then that's why we call them as a free electron. Then in a matter, Matter is made of what? Matter is made of atoms. And in these atoms, there are free electrons. In these atoms, there are free electrons. Matter are made of atoms, and in this atom there are free electrons. Then whenever we, okay, I'll show you example. Okay, consider these are two matter. Consider just an example. Consider these are two matter. This also is matter. It's made of atom. This also is matter made of atom. Now, when there are this also having free electrons, this also having free electrons. Whenever we rub them like this, or example, I rub like this. Whenever we rub like this, then this free electron, okay, consider this one having a free electrons, then this free electron from here is start to jump to this matter. Okay, those free electrons present in this matter, when you rub them like this, or example, you rub in your head like this, then those free electrons from here they start to jump to this matter. Okay, or example, we used to do those experiments. Okay, I'll show you example. Okay, now can you see this piece of paper here? Now if I write like this, I don't know this having free electron or not, this having free electrons or not, whatever it is a matter, then it may be having a free electron. Then whenever I write like this, there will be some electrons transferred from here to this pen, or from this pen to my head. I don't know. Okay, let me check. Wait, no attraction. No attraction. Okay, then let's check another one. No attraction. Then means there is no transfer of electron. Okay, on that example, okay, now look, can you see this paper here? Okay, I'll rub this matter. Okay, this small piece of paper here. Then I'll do like this. Okay, now can you see it is stitching with this pen? Okay, and it's fall down. Okay, can you see that one? There's an attraction. Okay, why the things happen? That is due to what? That is due to there is a transfer of electron from my hair to this pen, or from this pen to my hair. I don't know who's transferred. Okay. Then when there is a transfer of this free electron from one matter to another matter, when there is a transfer of free electron from one matter to another matter, it produces some force. It produces some kinds of force. And then this force is called electrostatic force. And this force is called what? Electrostatic force. Then this type of force of attraction, just now you see a piece of paper attract to this pen, and that why they attract, that force is electrostatic force. Why they attract, then it's a transfer of free electron from one matter to another matter. Then that transfer of electron, that transfer of what? Of electrons from one matter to another matter. That transfer of electron from one matter to another matter will be called as what they call charge. The transfer of free electron from one matter to another matter will be called as charge. Then most of students become confused, what is this charge? Then they used to think that charge also is an electron. Yes, it is an electron, but the transfer of that electron from one matter to another matter will be called as charge. Okay, example. Now these are two matter. Consider the free electron are transferred from this matter to this. The free electron transfer from this matter to this. Then these are losing because he transferred that electron to this one. Then this is gaining. Now this losing of electron will be called as positive charge. Then this gaining of electron will be called as negative charge. Then the charges has of two types. One is positive and one is negative. Okay, now you already know what is from where we got that charge, that is due to transfer of electron from one matter to another matter. Then from that particular case, then we call them as charge. Okay, let's come to the next part. Okay, now charge. Just now we have charge means the transfer of electrons. Okay, now we look here. Charge having positive charge and negative charge. Positive charge and negative charge. Then what is this positive? Okay, there are two matter. Okay, consider this is a one matter, and another this is a one matter. Consider this is matter A, then this is a matter B. After they finish to rub each other, that rubbing they produce some force of attraction, and that we call as frictional electricity. Okay, you will learn that in higher classes, in class 12. Okay, now consider this matter. This is matter A, and this is matter B, or conductor A, conductor B. Now once after we rub this each other, then consider this losing electron. This one is losing electron is given that electron to matter B. Then this will be denoted as plus because he is losing electron. And this one is gaining because this is given some electron to this matter B. And this gaining, then this become as negative. Okay. Now this positive and negative. Then this will become a positive charge. Then this is called as negative charge. Then what is our positive charge? How can we produce a positive charge? By losing what? Losing electrons. How can a positive charge be produced, or how can we get a positive charge? To get a positive charge means by giving some electrons to other. Means by losing electron, then that will be called as positive charge. Then what is negative charge? Negative charge means by gaining some electron. Gaining some electrons. Okay. Then how gain this electron? Means if we wrote, okay, how many electrons this matter A give to matter B after rubbing? After rubbing there is a transfer of electron. So this matter B are gaining the electron. Then this will be called as negative charge. Then how to get a negative charge, or how is negative charge produced? It is by giving some electron to that matter or to this conductor. Then will be called as a negative charge, or by gaining some electrons. Okay. Now at least you know what is charge. Charge means the transfer of electron from one matter to another matter. Then it has two types, positive and negative. And okay, then you know what is charge then. Charge means the physical properties of matter. Charge is, what's the definition of charge? Okay, definition of electric. Okay, electric charge. Electric charge. Because whenever there is a transfer of electrons from one matter to another matter, there is always some kinds of force is produced, some kinds of energy is produced. The force is produced is electrostatic force. Then energy will be electric current. Give a look about that. Then define electric charge. Definition of electric charge. This electric charge is the physical property. It is what? Physical property of matter. Okay, what is electric charge? Electric charge is a physical property of matter. Physical property of matter that it can attract or it can experience a force of. Okay, physical property of matter that when it is placed, physical property of matter that experience a force. Okay, physical property of matter that can experience a force of attraction, or repulsion. Physical property of matter that can experience a force of attraction or repulsion when placed, when interact with, or when placed inside an electric field. Okay, what is electric charge? It is a property of matter that can experience what? Experience a force of attraction or repulsion when placed inside the electric field. Okay, this will be the simple definition. And so many definitions of charge. Okay, but at least learn this one so that you don't need to be confused with other definition. Then what is this force of attraction and what is this force of repulsion? When this force of attraction occur, when this force of repulsion occur. Okay, we will look that later. Now, you already know what is charge is the transfer of electron in simple meaning. Then it has two types, positive and negative. And what is positive charge? When a material or a matter losing electron, then that will be called positive. Then what is negative? When a matter or a conductor or a material gaining electron, then that will be called as negative charge. Okay, then this is the definition of charge, and this will be mean the simple or the concept of charge that you don't need to confuse again. What is this charge? Don't confuse it with electron and charge. Electron is the elementary particle and charge is the property of matter. Look, electron is the smallest or the elementary particle present inside the atoms, and charge is the property of matter. That is a big difference between electron and charge. Don't confuse it. Then from where we get this charge? Whenever there is a transfer of electron or losing the electron, then we got a charge. Okay. Now we'll come to next properties of charge. Okay, we'll do only some properties. There are so many properties of charge. Let's we'll do only 4 or 5 properties, or maybe only we'll do the main one. Okay, number 1, the famous properties that this everyone knows it. Like charge are repelled, while unlike charge attract. Okay, what's the meaning of this? Like charge are repelled. Repels mean, what's the meaning of repel? Did you ever play with a magnet? When you take two magnets, consider this is a two magnet. This is a north pole, then this is a north pole, then this is a south pole, and this is a south pole. whenever you take this magnet, you put together with knot and you put it like this, then you cannot stick together. It will what I say? You try to push it to be stick together, but it cannot stick. Then that will be there. Some force who are pushing to each other. Then that type will be called as repel or repulsion. Then while unlike charge and attract means once I'll change this now. This is not. This is not. I'll change this up. Then once I put like this, you'll get attract, and they are stitching together. That will be called as attraction. Okay. Then what is like and what is unlike? Like means same kind. Like mean same kind. Then unlike mean different kinds. Okay. And what is the same kind? Mean positive charge and positive charge. Now out of this is same. This is positive. This is also positive. Then different mean positive and negative. Now that is different kinds. Now positive and negative. What has happened? Repel. We will look why they are repel. And negative and negative. This also same kind. Then this also repel. Then here, positive and negative, this is attract. Okay, why these are repel and why this also repel? Look, positive means losing of electron. Then if I take two matter, both are losing electron. This one also losing electron, this one also losing electron. There are, when they come together, can this one give this? Okay, this one also losing electron, and this one also losing electron. And when they come together, can this one give him some electron? No, because it's already loose. And can this one give him some electron? No, cannot give because he also already loose. And can they attract because they already loose? No, it's not possible. Okay, I'll show you something. Okay, remember this one that will be a simple way. Positive. In this positive charge, the direction of field produced, I mean the force produced by positive charge, I'll generally tell it's the force for you to easily understand. Because there is a 1 volt electric field, but I'll just give in simple is a force. Okay, now this positive charge, positive, the direction of force it produces always upward. Always upward, radially upward. Now this is upward, this also upward with all direction. Now if I take another charge here, positive again, then this also upward. And this also upward. Now if I take them together, can I put them together? Look, this direction, this is moving this direction, then this is moving this direction. What happens? This is moving this direction, then this is moving this direction. They are pushing each other. That force are pushing each other. Then they cannot attract. Then what happens? They will repel. And similarly for negative charge. For negative charge, when the force are like this. For negative charge, the force are always inward. The force are always inward. And if I take another one, here, then the force are always inward. Like this. Now, again, can they attract? Look, because this charge is pulling this direction. This charge is pulling this direction. Look, this direction. Then this one also pulling this direction. Then can they attract? They are pulling like this. Can they attract? They cannot attract. Then they will have to be repelled. Then what about this one? Positive and negative. Okay. Now positive and negative. Then here this is positive. Okay, negative. Then I'll put this one negative. Like this. Look here. Now this force, the force of this positive is moving in this direction, and the force of negative also moving this direction. Then this negative is attract this positive. This negative is attract the positive. Mean they are pulling that direction. Then they are attracting. What happens? When there occur attraction. Then this occur repulsion. Okay. Now always can you remember this? This is a simple or a basic one. Positive and positive are repel, negative and negative are repel, then positive and negative are attract. Then what about positive and neutral? Will they attract? Will they attract or will they repel? And what about negative and neutral? Will it attract or repel in this case? Can you guess? Okay. Positive and neutral, they attract or repel? I don't know. You give me the answer. Okay? You can give in comment. Okay. Give the answer whether attract or repel. Give the answer whether attract or repel. You give in a comment. Okay, I'll check it. Then once you give me the answer, when you finish to give me the answer whether they are attract or repel, I will explain it in next class. Okay, why this and this are repel or attract? I don't know. Why this and this are repel or attract? After you finish to give me the answer, then I'll explain it. Okay. Then now come to next property. Okay, now this is the first properties. And on side what is like charge mean same, and unlike charge mean difference. And repel mean pushing each other. Attract means they are what do you say? Attract. Repel, they are pushing each other like this. Pushing. Then this one is pushing that direction. This one is pushing this direction. Then they can okay like a magnet like this. Then attract. Okay, don't have any words. I can give 100 words for attract. Okay, really good. Okay, now come to next properties. Can you guess what is another properties of charge? First, we already get this one. Properties of charge. Okay, number one, and two. Then we go to number two. Charge are additive. They are additive in nature. Okay. What's the meaning of this additive? Charge are additive. Look, we already talked from the beginning that this is a one matter A, and this is another matter B. Now, here this one is losing, and this one is gaining. Now, can charge be added? Can number of charge be added? That is charge are active. Mean charge can be added. Mean how many charge present here? If again one more charge from here is given to this one, some electron again is given, then that means it count the number of charge. Then charge can be added. Okay. Then that's mean this charge are additive. Mean the number of charge present in matter B. Again we can add some more charge, but from another matter. Okay, that's meaning of charge are additive. Not addictive, additive. Mean addition. Then in that case we have like this. Mean total charge we can get like this Q1 plus Q2 plus Q3 plus blah blah blah. Mean Q is the symbol of charge. Okay, Q is the symbol of charge, representation of charge. Okay, then number three. Charge are quantized. Okay, charge are quantized. Okay, charge are quantized. What's the meaning of this? It means like this. Charge are countable. Charge are quantized means charge can be counted. How many charge are transferred? How many charge are losing? that is charge quantized with charge uncountable, it can be count. That in from here then we have a formula, and that is total charge, this one, this is total charge equal to n, mean the number of electrons or proton transfer. The number of electron transfer, this n stands for number of electron. Then into E, then this E is the charge of one electron. This E is, or we can call as the elementary charge. Okay, this is the elementary charge or the charge of one electron transfer. Then I'm going to write this here. Not yet, well. Remember, in physics, don't just, if I tell you write a formula of electric current or write a formula of force or whatever formula or expression you write. If the question asks write an expression for Ohm's law, then you write this: V is equal to I into R. Expression for Ohm's law example. If the question asks for an expression for Ohm's law, don't just simply write like this. Don't just say, okay, answer V is equal to I into R. Once you finish to write this formula, you have to tell what is this V stand for and what is this I stand for, what is this R stand for. Similarly here, what is this Q stand for? We have to tell what is this N stand for and what is this E stand for. If you tell what is this parameter name as, then you get full marks. But if you simply write like this, then I don't think so the examiner will give you marks, or maybe some examiners who are very spoon, then they'll give you some half marks. Okay. Then please don't forget to write the names. Where, what is this Q? Q will be known as a total charge. Then this N is the number of electron or proton. Number of electron or proton transfer or lose. Okay, number of electron proton transfer. And what does this E stand for? This E stands for as the elementary charge. Elementary charge. And what is this elementary charge? This is the charge present in for one electron transfer. In one electron transfer, how much charge it is? E. In one electron transfer, how much charge it is? E. And that is, it has a value. It has given a value 1.6 into 10 to the power minus 19 coulomb. Then this C is the coulomb. Okay, right here. What's this C stand for? Coulomb. Mean the SI unit of charge. The SI unit of charge. Okay, then this value 1.6 to 10 for minus 19 coulomb, from where we got this value, you will learn it in higher class. Okay, in class what way you do it? Now we got how many properties? One properties. One is like and unlike attributable. Then charge additive, it can be added. Then charge quantized, it can be count. Okay, let me write one more properties. This one will be the important properties. Okay. Now number 4. Or sometimes this can called as integral multiple. Integral multiple. Mean, what is the meaning of integral multiple? Mean like this. Mean that n is standard value as 1, 2, 3, 4, 5, 6. Means a counting means a natural number. Countable means counting number. Counting number. It comes again from where? From natural number. Yet integral multiple is a counting number. Or is a counting meaning it can be count. Okay, now comes to number 4. Number 4. Okay, maybe from here I'll ask you a question. Then I'll write it. Okay, because of this are 2 markers. Okay, this one marker. Okay. Okay. Now because of this marker, initially is at rest. Initially this marker is at rest. Now consider the charge here is 10 coulomb, example. At rest the charge is 10 coulomb, example. Then after that, it starts moving. It starts moving. Then while it is moving, the charge present here, it is 10 coulomb or is changing. Then in moving, that charge 10 coulomb are changing or remain the same. Remember this one. Charge is unaffected on motion. Whether you are in motion or whether you are at rest, the charge remains the same. It does not get affected. Then that is property number 4. Charge is unaffected due to motion. Okay. Charge is unaffected. Charge is unaffected in motion. Means charge will remain the same whether they are at rest or whether they are in motion. That is, charge at rest. Charge at rest is equal to charge in motion. Now, okay, these are the 4 properties of charges. There are some more, but we will do this 4. Okay. Now we'll come to what else next? Now we'll come to the definition of charge finish, concept of charge finish, and then properties also finish. Okay, now let's write first one question. And after that we'll come to next. Okay. How many electron are transferred or loose? How many electrons are transferred or loose? Should I give the question like this? How many electrons are transferred? How many electrons are present? Let me find out. How many electrons are present in 1 coulomb? 1 coulomb of charge. How many electrons are present in 1 coulomb of charge? First, what is this question? How many means the number of electrons. How many means the number of electrons present in where? In 1 coulomb of charge. Okay, can you solve this question? Okay, solution. How many electrons are present in 1 coulomb of charge? Okay, can you tell me what is given here? What is given in this question? Okay, given, because here we are going to use the last formula, Q is equal to ME. We'll use this formula to solve this particular question. Okay, how many electrons are present in 1 coulomb of charge? Okay, it given like this. Given charge mean 1 coulomb. Mean the symbol for charge is Q. And if here charge is how much? 1 coulomb. Then charge is given here 1 coulomb. 1C. This C stands for coulomb. It's an SI of charge. And remember, this coulomb is a very large unit. Okay, we'll cover later. Okay, Q is 1 coulomb, and then E. This is already we already got the value of E. What's the value of E? 1.6 into 10 to the power minus 19 coulomb. Remember this value, it won't give any equation. You have to remember it. Then, what you have to find how many electrons mean number of electrons. electrons that we have to find. Then n is equal to question mark. Now this is given, and that is the formula. Maybe you can solve it. What's the formula? We know. What's the formula? Q is equal to ME. And we need to find M. Okay, we want to find N and put like this. Okay, I'll change like this. Or kind of like this. NE is equal to Q. Say, just interchanging. This Q right from the side and this NE right from the side. Just interchanging. Then I'll take this E this side. Remember here in between what is present here? Multiply. Then n equal to, remember, multiply, whenever we take that side, it changes to division. Then Q divided by E. Then n is equal to Q divided by E. And then now we just substitute the value. What's the value of Q? 1. Then what's the value of E? 1 plus 6 times 4 minus 19. Okay, now put that value and solve. Then we know how many electrons are present in 1 coulomb of charge. Then you can know that 1 coulomb is a very large unit. Okay, then N. Then Q here is how much? 1 coulomb. Then E is 1.6 into 10 to the power minus 19 coulomb. Then coulomb and coulomb cancel. Coulomb and coulomb cancel. Then now left only how much? Now this decimal point is 1.6. Now remove this point. What we have to do? Okay, now remove this point. Now remove this point. What we have to do? Whenever we remove this point, then how many number after point? Only one number. And if there is a one number, then only 1 0 will come out. That means 110. 10 is coming out. Then you write like this. 16 by 10. But this 10 is from denominator, then I'll write it out. If there are two numbers, if example like this, then you'll be like this, and you'll having 2 zeros, mean 100. But here is only 1, then write only 10. Okay, then I'll put here 10. That 10 will raise up. Then what about this one? Now this is negative. Now if I take it up, because this you already learned in class 7, there's a law of exponent, that a to the power minus n is equal to 1 by an, or an equal to 1 by a minus n. And now this a minus n, this a minus n. Then if I take it up, it changes to a to the power n. And here it will be 10 to the power n, a to the power n. That is me. And here I'm doing that thing. Okay, I'll do like this. Now how many zeros here? There are 19 zeros. Then I'll take 1 0 from here and I'll do like this. 10. Here 10 is already there. Then I'll take 1 more 10 from there. 1 more 10 from this 10 to the power 19. Then left here only how many zeros? 18 zeros. Because 1 0 is already taken here. Then divided by 16. And now 10 into 10 will be 100 divided by 16 into 10 to the power 18. Then 100 divided by 16, you will get the answer. Okay, you do your division. Then 100 divided by 16, you will get 6.25 into 10 to the power 18. Look, in 1 coulomb of charge, in 1 coulomb of charge, there are 6.25 to 10 to the power 18 number of electrons. Means such a large value. In 1 coulomb, only 1, and this much number of electrons are transferred. What's the name of this? Other than this, or this will be like this: 625 into 10 to the power 16. If you don't understand what's the name of this, it will be like this: 6, 2, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16. This much electrons are present. Can you say how many trillion, billion? I don't know. Okay, now this is assembly. In 1 coulomb of charge, how many electrons are present? This much electron. Okay, you don't need to write this one. This two will be important. Remember, maybe they will give you as a multiple choice. In 1 coulomb of charge, how many electrons are present? They will give you option. This one, and under they give some different values. Then try to look either this one or this one. This will be the answer. Okay. This also will be same as this one. This and this. Okay. Now in one coulomb of charge, how many electrons are present? This much electron. Then if I ask you what is a 1 coulomb, define 1 coulomb of charge. What is 1 coulomb of charge? 1 coulomb of charge means, okay, we answer like this. When 6.25 to the power 18 number of electrons, when 6.25 to the power 18 number of electrons are transferred or loose, as compared to the normal state. Mean this much number of electrons are transferred or less, or mean they gain or less, or they exceed or they deficit. That's what you lose, whether they are transferred this much electron or gain this much electron as compared to the neutral state, then that transfer will be called as 1 coulomb. Okay, but that definition is not important definition, because this definition from this problem is not a basic definition of coulombs. Okay, but still I'll write for you. Okay, I'll write this one. Now we already get how many electrons present? I'll write it. Electrons. How many electrons 1 coulomb? That much. Okay, another question. Define 1 coulomb of charge. Okay, this definition is not that much important because it is not a basic definition. Just to give you a definition, because the basic definition of this you will do it in higher in class 12. Okay, define 1 coulomb. 1 coulomb of charge is just charge. Okay, we'll do like this. 1 coulomb of charge is that charge where 6.25 to 10 to the power 18 number of electrons transfer or loose. Number of electrons exceed or deficit as compared to the neutral state. And what? Look, 1 coulomb, it means how many electron transfer? This much from where we got this from here. And either this electron are transfer or gain. Either that electron are transfer from this matter or gain to this matter. Okay, I don't know whether this is gain or lose. Okay, that is the definition of 1 coulomb. And remember, what is the SI unit of charge? It is coulomb. Okay. Okay, now we'll come to. Okay, I'll write first this one. come to static electricity. Static electricity. What is that static? Static electricity. Electricity or electrostatic. In short. What is this static electricity? Static means rest. Yeah. Static means rest. The static electricity means it is a branch of physics. Electrostatic is a branch of physics which deals with the study of charge at rest, which deals with the study of properties of charge at rest, or the field produced by charge at rest, or the force produced by charge at rest, or the potential produced by charge at rest. That is electrostatic. What it is? It is a branch of physics which deals with the study of the properties of charge at rest. What is this properties? When these are the force produced by charge at rest, then the electric field produced by charge at rest, the potential produced by charge at rest. That will be electrostatic. Okay, then what is a dynamic electricity or what is a current electricity? Current electricity. Current electricity will be different from it. It is a branch of physics which deals with the study of properties of charge in motion. Here will be in motion, and here will be at rest. That's different. We will come to this one later. Okay. Now don't confuse what is a static electricity and what is a current electricity. Static electricity is the study of charge at rest, and current electricity is the study of charge in motion. That's different. Okay, then now we come to simple definition that you already learned from beginner's class, from class 6, class 7, or maybe from class 5, I don't know. But maybe from lower class you have studied it. What is conductor? What is conductor? Maybe insulator. What is conductor and what is insulator? You already know this definition. What's conductor? Conductor is a substance or a material that allow the electric current to pass through. Right? Is that a conductor? It's a material or substance. Materials or substance that allow electric current to pass through. Okay, that allow electric current to pass through is called conductor. Then what about insulator? It's a material or substance that does not allow the electric current to pass through it. It's called insulator. Right? Okay. But right now, why conductor allow current to pass through and why insulator does not allow current to pass through? Allow current. And here was why? Why this conductor allow electric current to pass through and why insulator doesn't allow? Okay. Why? Why conductor allow electric current to pass through? Because Because conductor has free electrons, and here no free electrons. Remember, whenever there is a free electron, whenever there is a no free electron, in which matter, those matter who have free electrons and those matter who doesn't have free electrons. And the matter which have free electrons, this will be in simple way for you to understand. Okay, matter which has free electrons, they allow electric current to pass through. Because why? Who carry the electric current? It is a free electron. If there is no free electron, electric current cannot pass. Okay, we will explain that later. Then here, if there is no, here because there is no free electrons, the current cannot pass through. Okay, look at this. Okay. As the outermost or the valence electron, remember the valence electrons or the outermost electrons, they are held loosely, or they are attracted loosely by the nucleus. Loosely by what? By the nucleus. Those free electrons here. Free electron. Those free electrons here are held loosely with not that much strong of attraction. Then this free electron they can move easily. Then once you apply, okay, consider this is a conductor. This is a conductor having some free electron. Because here in a conductor is a matter, it is made of atoms. There are so many atoms here. If there are so many atoms, then in one atom also there are free electrons. Then there will be so many free electrons here. Okay, example, there is a free electron here, free electron here, free electron here. Then whenever you apply some force from here, okay, you apply some force. What is that force? That is potential or energy. We will come to that later. Okay, when you apply some potential or energy, then these free electrons they start to drift. Initially, these free electrons, because they are free to move, they are moving randomly. Initially, these free electrons are moving. Okay, example, moving randomly. Converse this and the free electrons. Randomly means they are moving here and there like this. This one is this direction, this is direction, this is this direction, or maybe this is this direction. That is randomly. They are moving here and there, wherever they want to go. That is a free electron initially. Then once you apply some energy, or once you apply some potential, then this electron, like they get shocked. Suddenly, then they start to drift. Then this, once you apply energy, then this maybe they'll change their direction. They'll go like this, then move this direction. Or maybe they'll move this direction, we'll look to that direction, they'll move. Okay, from here. They start to drift. Okay, now exactly where this electron will move. Okay, I'll explain you that later when we finish to do what is this electric potential, where these electrons are moving. But remember now, why the conductors are allow electric current to pass through? It is due to the presence of free electron in the outermost shell of the atoms that are present inside the conductor. Okay, why conductors allow electric current to pass through? Because it has a free electrons present in the atoms. Okay, where that atoms is present in a conductor. Because if there is no electrons, means there is no charge transfer, right? If there is no free electrons, means how the charge are produced. Then when charge are moving, then only electric current are produced. Okay. I won't write that answer. Why conductor allow electric current to pass through? You write that answer by your own and send it to me. Okay. Why conductor allow electric current to pass through? Write answer by your own and try to send to me. And don't copy from textbook. From the textbook there is written like a newspaper. Then try to make it in short. And try to make it 3 lines maximum. Okay. Maximum 3 lines. Mean maximum 15 words or 20 words. Okay. Then why insulator does not allow? Same as conductor. But here, why insulator does not allow electric current pass through? Because they have some free electrons. But that free electrons or that outermost electron are held firmly or tightly with the nucleus. That free electrons or outermost electron are held firmly or tightly by the nucleus, so they cannot move. Then once you apply electric potential also, they cannot move, they cannot drift. Then so electric current cannot pass through it. Because electrons only carry that electric current. If there is no electrons, means no electric current. Okay. Now, up till now we did what is charge and what is charge, definition of charge, and types of charge, and properties of charge, and definition of Coulomb. And then we'll do that static electric current and current electricity definition. And then we did just now is conductor and insulator. And remember, what is the best conductor of electric current? The best conductor of electric current, remember, it is silver. Silver is the best conductor of electricity. This is among the metals. This is among the metals. Then what is the best conductor of electricity amongst the non-metals? Non-metals. Then this will be graphite. Okay. Silver, follow copper, follow aluminium. These are the good conductor of electricity, but silver is the best. Then graphite is best for non-metals. And silver is not only for electric current, remember. It is for heat also. Which is conductor is the best conductor of heat? Again, it is silver. That heat transfer, you will do in higher class, in bachelor. That also mostly, if you want to learn more about heat transfer, then that you have to go in engineering field, like mechanical engineering, have specific subject only for heat transfer. And it's very interesting. Okay, remember this, among the metals, silver is the best, and among the non-metal, graphite is the best. Okay, then we'll come to electric potential. This is denoted with symbol V. Okay. Then maybe you can ask why sir are doing randomly. Sir, they don't follow the textbook. Because in textbook they first explain charge, and then come to conductor insulator, then they will come to definition of Coulomb. Then after that, then we come to electric current. Then after electric current, we come to electric potential. But for me, I'll go first with electric potential. Because electric current is a charge is in motion. But here I'm doing electric potential because potential, just look fast. The properties of charge at rest. Properties of charge at rest. Or how that potential is produced. Okay. And before I'll do here electric potential, then I'll write here one more potential difference. I'll write here one more potential difference. P, or simply this also, or this one also we write V. Because these two terms, electric potential and potential difference, most of the cases or most of the students get confused. What is electric potential and what is potential difference? Because why is confusing? Because like this. Electric potential also will tell about the direction of where's the direction of current flows, and potential difference will tell where's the direction of current flows. And here, and here also, SI of electric potential will be. Okay, I'll write first like this. SI unit again voltage. Then here also SI unit voltage. Then measurement. If I ask you how can electric potential be measured? How can electric potential be measured? It can be measured by using voltmeter. Measured by using voltmeter. Voltmeter. And here also by using voltmeter. Look, both they are the same. As I need also volt, here also volt, here we using also voltmeter, here also using voltmeter. Or we can use another instrument, but let's do first this common one. Okay, and then what else? Both they are talking about energy. Electric potential also is energy. Then here also is energy. Both they are talking about energy. Then where is the difference? Because if you ask the example is electric potential, or if you ask what is potential different, the definition are slight difference. They are not exactly the same. But if you look here, they all are the same. And now I will give the explanation where is the difference. Okay. Now look at this. Consider here there is a charge. So you remember that charge has somebody's Q. Okay, consider this is a positive charge. Then I'll put there is a boundary. Because I'm not yet explaining about this. What is this? Okay, then here also I'll put a charge here. Then I'll put this boundary. Okay, then this will be the boundary. And here also this will be the boundary. Okay. Now remember, in last we have talked about this. Charge is always produce that force is acting out like this, that positive. Remember? Just now we finished. Remember, this will be talking about this one. I mean this line. You see this force? This is a line of force. Lines of force. Now this line of force is moving outward like this. Now up to where they can move? It can move only up to this line. Beyond this line, there will be no more force. Beyond this boundary, there will be no more line of force. Then this boundary or this area or here, where this line of force are present. This area here, where this line of force are present, is called electric field. What do you call it? What do you call electric? What do you call electric field? This area where this line of force are present, we call electric field. Or in short, this line of force we call as electric field. What is line of force? What is electric field? Electric field is a line of force. Okay, now this boundary. Now beyond this boundary, we call as beyond this boundary. We're not inside. I mean outside the boundary. This will be infinity. Infinity. And similarly here will be electric field, then here will be infinity. Because most of the students use that infinity. Most of the students, once we talk infinity, then they will say infinity, okay, infinity to space, mean out of the earth. Mostly, because infinity are very, very far. But here, in this case, mean infinity means outside the boundary, mean beyond the boundary. Okay. Now, what's the difference between electric potential and potential? Now, when you look at the diagram, also same. SI also same, measurement also same. It's talking about energy. Okay, work. Here also work. This is what we studied in class 9, previous class. What is work and what is energy? Okay, then now this. Okay, I can call this one as a source charge. This one as a source charge. Then here also source charge. This charge present here, I will call them as a source. I'll give you the name as a source. Now this source charge produces an electric field, that line force like this, R1. Then same here. Now if there is a charge from infinity, here is an infinity, right? Okay, infinity. Now put here as a small charge, Q0. I just give a symbol for small charge, Q0. This small charge or positive charge, why I consider it small, I'll explain you later why. This is source charge considered as a big one, but this is a small one or two hour. Okay, this is a positive test charge or a small charge. Now this is infinity. Now let me consider there's a one point here. Okay, consider this point A. Point A. This point A is where it is inside the electric field. This point A is present inside the electric field. Of whom electric field? Of the source charge. This point A is present inside the electric field of the source charge. Okay. Then now, this small charge, this is a small charge. Okay. Now this is the boundary of this small charge. Because this charge, all the charge are produce electric field. Now this charge also produce electric field. Now this line is boundary. Now this one are very small, this one are very big. Okay. Now this small charge, I want to take this small charge to place it inside this electric field I point A. I want to take this small charge, this positive test charge, small charge or positive test charge, to take from infinity to place it at point A inside the electric field of what? Of the source charge. Okay, I'll take this source charge to a point A. Now this, if I take it, I need some work to do, right? Okay, consider here this one. Now if I want to take this marker from here to here, then I have to apply some work, right? I have to apply some work, I have to give some energy, I have to spend energy. Then same here, to take this charge from here to here, the point A, then I have to spend some energy, in some work. Right? That's why I told you electric potential is energy. Then I have to spend some energy. Okay, then how do we find what is electric potential? Electric potential, it is the amount of work. You give some work, you apply some work just now from here to here. It is the amount. Amount means how much work you apply. That's the meaning of amount. What's the meaning of amount? Means how much work you apply. Means it is the amount of work in bringing things from where? To take this charge from here to here. In bringing this small positive charge from infinity to a point A or to a point inside the electric field of what? Of the source charge. That is called electric potential. What is electric potential? The amount of work done in bringing this small positive charge from infinity to a point inside the electric field of the source charge. That is called electric potential. Okay, and what about this potential difference? Now again, I'll explain that potential difference also here. Then I'll put another point here. I'll take point B. Okay, now look about potential difference. Now let's take here the potential at this point A. Okay, I'll put this point A here. I'll put this point B here. Then let's take this point, it has a potential of VA. Then here, point B has a potential of VB. Okay, now what's the electric potential? The amount of work done in bringing a small positive charge. The amount of work done to carry that charge from infinity to this point. From infinity to a point. From infinity to a point. Inside the electric field of the source charge is called electric potential. Then what about potential difference? Potential difference also same. The amount of work done in bringing load. Again work. You need to apply work. You need to apply again energy. But what's different now? Can you see what's different? Here is electric potential and here is the potential difference. Can you see what's the difference? Electric potential is from infinity to a point inside the electric field. But here, potential difference. from one point to another point. From one point to another point within the electric field of what? Of the source charge. That's different. Electric potential is from infinity to a point inside the electric field. But potential difference is the amount of work done. Same like definition like this. Right then, the amount of work done in bringing a positive small charge from one point, because this charge is already here, from one point to another point within the electric field of the source charge. I got it. What's the difference? Where's the difference between potential difference and electric potential? That's different. Now look here. Then which one is higher potential? Point A or point B? Which one has the higher potential? Point A and point B. Remember, the one who are always close to the charge. The one who are always close to the charge will be has the higher potential. Okay, now point A are very far from Q, then the electric potential here are very small. Then point B are very close to point Q, then the electric potential here are very large. Look here. Electric potential here, electric potential here. The difference between these two electric potential difference. You got it? Look, from infinity to a point A, electric potential. From infinity to a point B, electric potential. From infinity to a point B, electric potential. From infinity to a point A, electric potential. And the difference between these 2 points will be called as electric potential. You got it? But definition is not like that. Most of the students they write like this. What's potential difference? The difference between two electric potential, or the difference between the higher potential and the lower potential is called potential difference. Yes, because this is higher, this is lower. Because I told you, this point B is close to Q, it has a higher potential. This is higher potential. The point A is far from Q, this is a lower potential. And the difference between these two, because the potential different. Okay, but the definition don't write like that. Okay, I'll write the definition now. Okay, electric potential, the amount of work done. The amount of work done or energy spent. Remember that when you take this marker from here to here, you have to spend some energy. That means that you have to do some work. Then the amount of work done in bringing what? Bringing this small positive charge. In bringing the small positive charge. In bringing the small positive charge from where? From infinity to a point, this point or this point, whether which point, A or B, to a point inside the electric field of the source charge. Source charge. Now that's the definition of electric potential. Now what's about definition of potential difference? The difference between the higher electric potential and lower electric potential? Yes, that we can write. But that is not the definition, the correct definition. That is a formula. Okay. Now what is this? The amount, say by that one. the amount of work done in bringing a small positive charge from where? From one point to another point. From one point to another point within what? Within the electric field. Within the electric field of the source charge. Now, can you see where's the difference in definition? The difference is here, from infinity to a point, and here from one point to another point within the electric field. Now, there is a difference. But the SI width and everything will be the same. I told you electric potential to bring that small charge from infinity to a point, to bring from this point to this point, from infinity to a point. Okay, then we can write that as the formula. Electric potential symbol is V. Electric potential V. Then we have to spend some work. We have to spend some work where? Okay, work. To carry what? To carry the charge. Okay, so heavy. We have to spend some work to carry the charge. Okay, then that charge will make the work or the energy will lose. Or energy will be loose. Then I'll divide it. Because now if I divide this work by this Q, then it will be loose. Okay, by Q. Okay, Q now. Now electric potential is a work per unit charge. Now what's electric potential? We look from here. Electric potential, V. Electric potential is a work per unit charge. Electric potential is a work per unit charge. Then what about this one? This one also is a potential difference. Okay, that is potential difference is a work between point A and point B, right? We take from one point to another point. I'll take like this: A, B by Q. Right? Work between A and B by Q. Or another is potential difference, or V, is equal to VA minus VB. Because this one, okay, I draw first here because that side cannot be seen anymore. Another here, okay, PD is equal to this one, like this. Work at point A with electric potential at point A. At point A, which one is a higher potential? Point B, right? Point B is higher potential. I've got this. Work at point B minus work at point A divided by Q. Now this V, the work by Q is equal to V. Then we have this potential difference, or V, is equal to V at point B minus V at point A. Because this is work by charge. Work by charge is equal to V. Then here also work by charge is equal to V. And here the potential difference is. Now most of the students, if asked what's electric potential, they will answer this. The difference between the higher potential and the lower potential is called potential difference. Right? Now please don't confuse this. What is electric potential and what's potential difference? Here's bringing from infinity to a point, and here's bringing from one point to another point. And okay, then as I need we already written from the past, then now here I write this as I need here. What is SI unit of work? You have studied in previous class in class 9. What is SI unit of work? Work, and SI unit of work is joule. And SI unit of charge, just now we finished, is coulomb. Coulomb. Then you can write this. Electric potential is equal to electric potential. Electric potential is joule per coulomb, right? Joule per coulomb, or in short we write as voltage. Then symbol for this V. Symbol for volt VV. And similarly for potential. SI unit potential also will be same as electric potential. And measurement voltmeter, measurement voltmeter. We will look what is that voltmeter and how it is connected, and we'll look back. Okay, then I'll take rest for 5 minutes. Okay, now just now we got that formula. V is equal to W by Q naught, and one more we got. V is equal to VA minus VB, or VB minus VA. VB minus VA for VB is greater than VA. Now if VA is greater than VB, then write this VA minus VB for VA is greater than VB. Okay, but I told you from the beginning, whenever you write a formula, always tell what is their names, their parameter names. And here where V, what does this V stand for? Electric potential. Electric potential. And here the W stand for work done. Work done at point A or point B. If I put here WA and work done at A, then WB work done at B. Okay, then this one is Q naught is a charge. Okay, I will simply write it charge. Then here, what is this V? Here, all potential different, right? This one here will be potential difference. Then this VA potential or electric VA electric potential at A. Then VB electric potential at B. Okay. At least whenever you write a formula, if you ask you write the expression of electric current formulas or expression of this, always remember tell their parameter names. Okay. If you bring your friends to your home, or if you come along with your friends to your home, you will tell your mom that his or her name is, right? And similarly here, if you just simply write this formula and give it to the examiner will look and say, okay, he don't know what is this W stand for, what is this Q stand for, because you don't tell him. Then how you tell him? By writing here. Where V is equal to electric potential, then W is equal to work done, then Q is the charge. Okay, then now come to define. Okay, I got first this one, I write the expression. Now the board become hard to write. Okay, now let me ask you a question on this. What is its SI unit of electric potential. What is this idea of electric potential? And define it. And define it. In define unit of electric potential. Define unit of potential, or they ask you define one word. Or if you can give like this. Or define one word. Let me give you this question also. Okay, the answer comes like us. What is SI mean? SI means electric potential. Already know what is? SI mean is voltage. SI mean is volt. Okay, in short, right, volt. SI mean is volt. And then define it. Okay, now I'll write here. Define the definition. Okay, to define, I won't define it directly. Okay, first I'll write with a formula. Then we'll put some value. Then after that, we'll define it. So that will be easy for you to remember. Because to just direct write the definition, because there are so many like this definition. Define 1 volt, define 1 ampere, define 1 joule, define 1 ohm, then define 1 Newton, so many 1, you'll be get confusion. Then define 1 Newton. Then for that reason, then first I'll write the formula. If we ask you define 1 volt or electric potential, you already know what's the formula of electric potential, right? Then always start this. What's the formula of electric potential? Okay, we know. Electric potential V is equal to W by Q. V is equal to W by Q. Is this a formula of electric potential, right? Then I put like this. Let W is equal to, what are you given here? 1, right? Okay, I'll take this. Let W is equal to 1. What's the SI unit of work? SI unit of work will be joule. SI unit of work will be joule. Then just consider let W is equal to 1 joule. And then Q is equal to, what's the SI unit of Q? Coulomb. Then let W is equal to 1 joule. Let Q is equal to 1 coulomb. Then therefore, what is V? V is equal to, in place of this W, I put 1 joule by 1 coulomb, then this is equal to 1 volt. This is equal to 1 volt because SI unit of electric potential is volt. Then now write the definition. Thus can we define by 1 from here? Look, when 1 joule, what is this 1 joule? So wow, when 1 joule or 1 joule of work is done, 1 joule of work is done in bringing 1 coulomb of charge. In bringing 1 coulomb of charge. When 1 joule of work is done in bringing 1 coulomb of charge from infinity, you remember that definition? Take from that definition. From infinity to a point inside the electric field is called 1 volt. Or you can say that this. Electric potential is said to be 1 volt. This V is electric potential, right? Then electric potential is said to be 1 volt when 1 joule of work is done in bringing 1 coulomb of charge from infinity to a point inside the electric field. Finish. Just this is the main part. Okay. Electric potential is said to be 1 volt. Yeah. Electric potential. Electric potential is said to be 1 volt. Electric potential is said to be 1 volt. Electric potential is said to be 1 volt when 1 joule of work is done in bringing 1 coulomb of charge, 1 coulomb of charge from where? From infinity to a point to a point inside the electric field. That is the definition. If we ask you, define the unit of electric potential, this will be the answer. If we ask you, define 1 volt, this will be the answer. Okay. Now we finish electric potential and finish the difference, potential difference in SI wave. Okay. Now we come to how electric potential be measured. How electric potential can be measured? Or if I ask you, name the instrument used to measure electric potential. Or you can ask me this. Or name the instrument used to measure electric potential. Name the instrument used to measure electric potential, or they can ask you again here, I'll continue the question. If they ask you separate also, so that you remember how electric potential can be measured, or name the instrument used to measure electric potential. How it is connected? How it is connected? How it is connected in an electric circuit? How it is connected in an electric circuit and why? Because it is connected either in parallel or in series. We will look at that if connected in series, why? It was connected in parallel, why? Okay. First, how is connected in electric circuit? I'll write first the answer for that. Then after I'll come to why it is connected in that and why it does not connect in that. Okay. Then remember, if they ask you the answer here name instrument used to measure electric potential is a voltmeter. If they ask you what is a voltmeter, it is a device which used to measure electric potential, which has a high resistance instrument. Okay, remember. If they ask what is a voltmeter, okay, I'll write that question later. Okay, answer for this. Name instrument, answer is voltmeter. Voltmeter. And how it is connected? It is always connected in parallel. It is always connected in parallel. If I ask you why voltmeter is connected in parallel in an electric circuit, we will come what is electric circuit also in next in next video. Okay. Name instrument used to measure electric potential, voltmeter. Then how is connected in the electric circuit? It's always connected in parallel. If we ask you why, now we come to the answer. Okay. Question. Why voltmeter is connected in parallel? Why voltmeter is connected in parallel? Can you guess why it's connected in parallel? Maybe you don't. Some students know, and maybe some students don't know. Because maybe they don't know what is that parallel means also and what is that series also. We will come to that. Okay, don't worry. Now, at least first I will explain why is voltmeter connected in parallel. Okay, I'll show you an example what is parallel and what is a series. We will do separately for that. Series connection. Series connection means join one after the other. Join one after the other. What is that? Join one after. Series connection means join one after the other. Okay, example. This is the one electrical appliances. One electrical appliances means the components of electrics. Okay, example, bulb, switch, and then your TV, your refrigerator, whatever that we call as electrical appliances. Okay, example, this is the one electrical appliances, then this is another electrical appliances, they are joined one after the other, then one more joining here, one after the other, then one more joining here. They join in series. They are joining continuously. That will be called as series. Then what about parallel? Parallel connection means the joining of electrical appliances are two common point being joined at two common point. That's the difference. What's the series? Join one after the other. Okay, join here, then join here, then join here, then join here. They are continuously. Then what about parallel? Parallel means they join only at two common points. Okay, example here. There's a one instrument. Okay, this is a bulb. So this is a bulb. Okay. Then there's one more bulb. Okay, in series around this. One bulb here. Then again one more bulb here. Again one more bulb here. They are joining serially, like a series, in a series. But for parallel, one bulb here. Then one more bulb here. Did they join? No, not they join. But this bulb are joined to this point, then this bulb are joined to this point, then this also joined to this point. Now this also joined to this point. This also joined to this point. Now are they joining at only 2 points? That is joined at two common points. Okay. Now that is the difference. What is a series and what is a parallel? Okay, we will look separate for that. Okay, in separate video. Okay, before you understand why voltmeter is connected in parallel, you already know at least what is a parallel connection. Then we have to know first, voltmeter is a high resistance or a low resistance instrument. Again, you ask what is the resistance? Okay, that also we will do later. We will do in the next video. So many new things here. Some students who are already known and being easy for you, and some students who are not yet known, maybe they are what is that resistance? Okay. Remember that voltmeter is a high resistance instrument. Voltmeter is a high resistance instrument. And why it is high, so we will look to that later. Why is made with a high resistance? Why it doesn't made with low resistance? Why voltmeter is connected in parallel? Okay. Now because remember, voltmeter is a measurement for electric potential. Remember, electric potential is only measured between 2 points. Electric potential is measured only between 2 points. Okay, example here. This is a bulb. Now, if this is electric bulb, okay, electric bulb. Now this is electric bulb. If I want to know how much is the potential are passing through, or how much energy are passing through this bulb, are given to this bulb, then I should not connect like this. If I can, okay, I put here voltmeter like this. Now this is not a parallel. This is a series. Now if I put like this, then this it won't tell me how much is the potential, electric potential pass through this bulb, because the current are flowing from here, then go from here. Look, the current are passing from bulb, then again passing from the voltmeter. And this voltmeter is connected between, look, this is not parallel. Then it always connect like this, because we just want how much is the potential of this bulb, then I connect that potential electric voltmeter from here. Now look here. This bulb is connected to this point. Now this bulb is connected to this point. And this voltmeter also connected to this point. This voltmeter also connected to this point. Right? They connect only at 2 common points. Then now, when the current pass from here to this bulb, when the current pass. Current is, remember the current symbol is I. Okay, we'll come to that. What is electric current? Now the electric current symbol is I. Now this current is passed. Okay, let's say here is a battery supply. Positive and negative. We will come to that also later. Okay, now remember, consider there's a current pass from here. It passes the bulb. Now remember, because here there are two ways. At this point there are two ways. Like the water can flow. If there is a two-way water coming from here, then goes this side some amount of water and some amount of water this side. Then similarly for current, some amount of current will pass from this way, and some amount of current will pass from this way. Okay. Then for that reason, then they make a voltmeter a high resistance. Because if there is a high resistance, the amount of current passed will be very, very low. Because we don't want the current to waste. We want the current to pass from the bulb so that the bulb will glow. We want the current to pass from the bulb so that the bulb will glow. Then we don't want the current to waste to pass from the voltmeter. That's why we make voltmeter as a high resistance. Why voltmeter is made high resistance? So that we don't want the energy or electric current to waste. Because we want that electric current to be used by the bulb. Okay, then this is high resistance, then a very low amount of current are passed from this direction, then large amount of current will pass from this bulb. Okay, then from here only small amount of current are passing here, then this voltmeter can tell how much is the potential passing from this bulb, given energy to this electric bulb. Because it measures only from this point and this point. Then this voltmeter, it doesn't tell how much is electric potential through the whole circuit. Because I connect here only for this bulb, then it will tell only for how much potential for this bulb only. Okay. Then if you want for whole circuit, then we have to connect in another way. If you want the whole circuit, then we have to connect on this. Okay, I put one more voltmeter here, like this. Then connect like this. Now this will tell the whole amount of electric potential. Okay. Why voltmeter is connected in parallel? It is connected in parallel. It is connected in parallel because electric potential is always measured at a two common point. That is the answer. Okay. Now we finish how electric potential is measured by using voltmeter, and how it's connected in parallel, and why it's connected in parallel. Also you already got the answer, and why it's made a low resistance. That's what I've already explained, but I won't give the answer for that. You write on your own. I'll give the question. Why voltmeter is made with high resistance? this will be the question for you, and write it and complete it and send it to me. Okay? Then now we'll come to the last topic of this class for today, of this class. That will be, we'll come to charge in motion. What we had finished just now on, that will be called is a charge at rest. Okay, then now we'll come to charge in motion. Exactly this electric current is not that. It is charge only. Charge also is not that, it is an electron. And for the transfer of electron we call charge. Okay. Then now this charge in motion. Whenever a charge is in motion, whenever a charge is in motion with respect to time, then that will be called as electric current. Then what's electric current? Electric current is simply the moving of charge. Then exactly that's what electric current. We simply call it, in place of that moving of charge, so many words, then we call them electric current or current. Okay, but before we understand the meaning of electric current, you already know electric current, just now I told you. Electric current means it's a moving of charge. Okay, but before we learn what is this, then first I want to understand what is the meaning of current. Because most of the students, once they said current, in their brain or in their whatever in their mouth, once we talk current, then you said about electric current. This current that you use at home for charging your mobile or for connecting your TV. Exactly, current is not only for that. Current means any types of flow. Any types of flow also called as current. Then because here whose flow? Charge are flowing. Mean electron are flowing. That's why we call current. Current mean the current of electron, mean the flow of electron. Okay, then what's the meaning of current? Current means flow. Even the water also are flowing. Then we call that current. Water current. You heard that in geography, you have studied in geography. Water current. Mean what? Flowing of water. Then any types of flow will be called as current. Then here electric current means who flows? Electric current means charge are flowing. Mean electron are moving. That is electric current. Current means flow. Then electric means charge are flowing. Okay. Then what's electric current? The flow of. Mean current means I already told you flow. Then the flow of charge. The flow of charge per unit time. The flow of charge per unit time. Or the charge. Okay, the flow of charge per unit time. Flow of charge in a conductor. Okay, I'll express some more. So there will be a complete definition. The flow of charge in a conductor. In a conductor. Not in an insulator, because insulator current cannot flow. Then the flow of charge in the conductor per unit time. Flow of charge in the conductor per unit time is called an electric current. The flow of charge in the conductor per unit time is called. Now this is no more electrostatic. Okay, this will be current electricity because the charge is in motion. Now here's the charge in motion, no more charge at rest. Charge at rest is a very lengthy topic. Okay, but here in your syllabus, they just give a brief introduction about charge at rest and just do that part only according to your syllabus. And the flow of charge in a conductor per unit time is called an electric current. Okay, then we can write this in term formula, that is, remember electric current is denoted with I. Electric current is denoted with capital I or small I. equal. And remember, this formula is just an average current, not instantaneous current. There are average current and instantaneous current that you will learn it in class 12 or in higher class. But right now we just talk about electric current. Electric current, we don't talk about instantaneous current or average current. Okay. Then I here, electric current, the flow of charge in a conductor anytime is called electric current. Electric current is defined as the charge per unit time. Then I told you, when we finish to write this, we have to tell what is that Q and what is this T. Okay, Q is the charge flowing in a conductor. Then T is the time taken for the charge to flow. Then I is the current flowing. Okay, one more I forgot to tell you. What is electric potential is a scalar or a vector? Electric potential, remember, it is a scalar quantity, and charge also is a scalar quantity. That too I forget. Okay, electric potential is a scalar quantity, and charge also is a scalar quantity, and even electric current also is a scalar quantity. Okay, now remember, maybe student will get confused. Why electric current is a scalar quantity? Because electric current has a direction. Because electric current has what? Has a direction. Then you draw like this. This is a conductor. Now the current are flowing in this direction. Then it has a direction, right? Then if there is a direction, then it should be a vector quantity. Because vector means has a direction. Scalar means no direction. But here current has a direction. It moves from positive charge to negative charge. From positive terminal to negative terminal, current are moving. Like this is conventional current. Then we have to tell that electric current is a vector quantity. But no, it is not. But still it is a scalar quantity. Why? Remember this. It is a scalar quantity. But why it is a scalar? Because even though electric current has a direction, it moves from positive to negative, and it also has a magnitude. But why still it is a scalar, it's not vector? Because electric current is electric current can be solved or can be added by using a simple algebra, not a vector algebra. For electric current, you cannot apply vector algebra. You cannot write this I vector. Because electric current you cannot apply vector algebra, is only can be applied by simple algebra. That we can write this. I is equal to I1 plus I2, either or equal to minus I3. This is simply a simple algebra, not vector algebra. That's why it is a scalar quantity. Because scalar quantity can be used by simple algebra, can be calculation, and vector quantity can be used by vector algebra. That's different. That's why electric current is still a scalar quantity, because we cannot use vector algebra for electric current. Okay, and then what is SI unit of here? Now SI unit of electric current. SI unit of electric. What's SI unit of charge? SI unit of Q. Q means charge. SI unit of charge will be coulomb C. Then SI unit of time will be second. And put like this. C per S. Okay, I'll write France like this. Coulomb per second. In short, C per S. But there is one word for this, or ampere. Symbol A. For electric potential, voltage, and for electric current is ampere. But remember, whenever we write SI unit of electric current, don't write this ampere. Always write this way. This should be small letter, not capital letter. If you write capital letter, then this will be the name of that scientist. Okay, then if you put small, it is SI unit of current, ampere. But in symbol, we write capital. But for if you write a full name, put small letter. Okay. SI mean coulomb per second or simply ampere. Okay. Then can we define SI mean? Okay. Again, let me ask you, what is the unit of electric current, and define it, or define unit of electric current. Unit of electric current is ampere. Then define 1 ampere. It will be same like electric current. You may ask that. Define the unit of electric current. Define the unit of electric current means define 1 ampere. Or define the unit of electric current. Or what is the sign of electric current? Ampere, and define it. Okay, then the answer for this will be we'll do same like electric potential. I'm going to define it directly. We'll write first the formula. Okay. Answer. We know I is equal to Q by T. Is this the formula? Okay, then let Q is equal to 1 coulomb and T is equal to 1 second. And remember, this definition define 1 ampere also is not that much important, because this is not a basic definition of ampere. There's one more definition of ampere that we do in higher class. But right now, in your syllabus, I will just do this one. Okay. Then Q is equal to 1 coulomb and T is equal to 1 second. Then therefore, I is equal to 1C by 1 second equal to 1 ampere. Now from here, can we define thus? What is this? How we define it? Can define it? Electric current is said to be 1 ampere. This I is electric current. Electric current is said to be 1 ampere when 1 coulomb of charge flows in a conductor in how much second? In 1 second. It's called 1 ampere. Okay. Now, or should we start from here or should we start from here? That doesn't matter. The sentence should be the same. Okay, I'll start from here. Electric current is said to be 1 ampere. Okay, electric current is said to be 1 ampere. Said to be 1 ampere when 1 coulomb of charge flows through a conductor. Flows through a conductor in how much second? In 1 second. How much second it flows through a conductor? 1 second. Then that is electric. That is 1 ampere. And this would be the definition of define 1 ampere or define the unit of electric current. Okay, this is very easy. Electric current is said to be 1 ampere when 1 coulomb of charge flows through a conductor in how much second? In 1 second. Okay, now we'll come to next. Name the instrument used to measure electric current. In electric potential, voltmeter, but here it is ammeter. Now again here, ammeter is connected, I'll be fast. Ammeter will be connected in voltmeter connected in parallel, but ammeter connected in series. Then wire is connected in series is similar to voltmeter only, but there is a difference. And ammeter is a low resistance device. It is not a high resistance like voltmeter. Okay. Name instrument. Name instrument used to measure electric current. Answer will be ammeter. Okay. Note this one. it is connected in series, and it is a low resistance device. You already know what's meaning of series and resistance. I'm going to explain. Okay. Then why is a low resistance device? This will be important. Maybe they'll ask you. Okay. Why is a low resistance device? Because it is connected in series, it has to be low. Otherwise, it will be wasting energy. Okay, look here. Example, there's a bulb here. Connected in series means they join one after the other, right? In series means join one after the other. We have talked just now. Then here maybe there's a ammeter A. Now this is connected in series. Okay, let's say this is a bulb battery. Here is a switch. Okay, now current are moving from this direction. Okay, now imagine if this ammeter, it is a high resistance. Remember I told you whenever there is a high resistance, the current will be reduced because a large amount of energy need to spend here. Large amount of energy need to spend because it is a high resistance. Then we don't want that. We want that all the energy is spent on this bulb. We want that all the energy is spent on this bulb. Then we don't want to waste. Then we make this ammeter to be a low resistance, so that the current can easily pass through this ammeter. Then the large amount of electric current will pass through the bulb. We don't want that electric current will be wasted here. That's why it is made a low resistance device. Then we just want how much is the current pass through. That's only our purpose. We don't want to lose that energy. We just want to know how much is the current pass. Why? Can you write your own answer? The reason why we need low resistance because the energy consumed will be very, very low, so that the whole circuit, so that the energy is spent the whole thing by the electrical appliances. We don't want to waste that energy in only for measuring it. Just to measure waste large amount of energy, and that's why we need low resistance. Okay, answer. Okay, you can try my own and write the answer. Okay, then series. Now don't confuse what is electric current and what is electric potential. Electric current is measured by ammeter, and electric potential is measured by voltmeter. And the sign of electric potential is volt, and the sign of electric current is ammeter, and it is connected in series and it's a low resistance, and voltmeter is connected in parallel and it's a high resistance. Okay, then the basic problems of this topic, of this class today, or of this class, we will continue in the next video. Okay, then thank you. Do like, share, and subscribe this channel. Then we will be back in the next video. We'll continue on from this part. We'll do the problem related to this electric current, electric potential, and after that we'll come to electric circuit. Okay, thank you.